All right, so now we know how to do one-step equations when you're solving with either addition or subtraction. And we know how to do two-step equations when you're solving using multiplication or division. And we know how to do two-step equations where you have both in the same problem. So that would be two-step. Now we're going to start looking at more steps. And the first additional step we're going to look at is solving when there are variables on both sides. So let's just get right into an example. So we want to solve 5k minus 8 equals 7k plus 18. Okay, this one's a little bit crazy because remember, solve means to get the variable alone on one side. And up until now, we've already only had one variable on one side. But now I have the variable on both sides and it's hard to tell what to move around. So in front of what we already do, the first step in this case is now going to be to get the variables together on one side. Ooh, that took a long time, a lot of silence. So I want to get the variables together and I'm going to use exactly the same operations I'm used to. This is a plus 5k on this side, and this is a plus 7k on this side. So I have some choices. I can either move the 5k to the right-hand side or the 7k to the left-hand side. Now, there's an idea or there's a better option, but it doesn't really matter. You can do both of them, either one you choose, and with time you'll start to see the better option. And I'm going to tell you that the better option is to move the 5k. So we're going to do just like we always do. To make a positive 5k disappear, I'm going to put a negative 5k on this side, and that makes it disappear on this side. So I'm doing exactly the same thing, except instead of moving an integer, I'm moving a number with a variable attached to it. Same thing I do usually, just clean up. So I have negative 8. And then on this side, I have to combine these terms, right? Combine like terms. So you can do this in 2 steps or in 1 step. I'm going to do it in 2 steps. And the first step I choose is optional. You can either do it or not do it. Whichever one you choose, though, you want to end up in the right place at the end. First is to group the terms together, 7k, and then a minus 5k, and then the plus 18. Sometimes it's easier to see what you're going to combine if you put them all together on the same, or all together. So you have a minus 8 equals 7 take away 5, so 7 green marbles, take away 5 green marbles, leaves 2 green marbles, plus 18. Okay, this step is the optional step. You can either have it or not have it. I'm going to do that because it's optional. If you can group the 7 and the negative 5 together and end up with 5k without rearranging them, go for it. If you struggle with that, you should take the time to write the middle step and get to the right place every time. Now I just have a problem that looks exactly like every other problem you've ever done, except I like to have my variable on the left-hand side. So I'm going to move all the left-hand side to the right-hand side. 2k plus 18 equals, and then all the right-hand side to the left-hand side. Excuse me, all the left-hand side to the right-hand side. I just like my variable on the left-hand side, so I switch them back and forth when I'm working problems. This time, I want to get rid of the 18 first, so now I'm doing just what we already know how to do, which means I'm going to subtract 18 from both sides, so it disappears there. So I have 2k equals negative 18 minus 8 is negative 26. 2 is connected to k by multiplication, so I want to turn a multiplied 2 into a divided 2, which makes it disappear on this side. And so k equals negative 2 divided by 2 is negative 1 times 6. And then this is where I would check my answer. I'm not going to because I think you guys are already really good at checking your answers. And I don't see any reason to use lecture time video time to check answers knowing that you know how to check. But just know you're still required to be checking your answers. In pre-algebra, you always check these values in your original problem. All right, one more example or another example, and this one throws a little bit of a surprise at you. Let's solve, well, it throws actually two surprises, interestingly enough. Let's solve 4 times negative 2 plus 3x, and that equals 12x. Okay, so the first thing we want to do is solve for x. Look at this side. This side is not completely simplified. What would you move over here? You can't just come inside and take this 3 and move it over here like this, because this 3 is part of a binomial, and you can't just disappear half of a number. You have to take the whole number. I could divide this over, but that's kind of crazy. So what we really want to do is PEMDAS in its normal order, PEMDAS. And we're going to work down because we're simplifying. We're not going to cross this line. So this line here for the first step, we're not going to cross it. What we're going to do is distribute 4 times negative 2, or distribute the 4 into the binomial. 4 times negative 2 is negative 8, and then 4 times positive 3x is plus 12x equals 12x. Notice how I didn't move anything from one side to the other? That's because I wasn't completely simplified on this side. So you have to completely simplify one side before you can start moving things over. Remember that. You always PEMDAS down, and then you can turn around and PEMDAS up for solving, but you have to do the simplifying on both sides first. So now I have 12x on both sides. Let's take this one. This is a positive 12x, so I'm going to subtract 12x from both sides, which makes that one disappear. And then I'm left with 8. Negative 8 equals 12x. Take away 12x is 0. Hey, wait a minute. That's crazy. What happened? Sometimes you get these funky answers like this, and when you get to the end and your variable disappears and you get something that is obviously crazy town, because negative 8 and 0 are never equal to each other, that means there is no answer for this equation. There's no solution. There's no value of x that you could ever plug in all the way out by infinity or as close to little tiny fractions as possible. There is no value for x that will ever make this true. So this equation actually has no solution. Isn't that weird? But that's the way it is sometimes. All right, so we have another one with another, I'm going to warn you, it has another kind of wonky outcome at the end. So let's see. Let's take 7 times 2x plus 3 equals 21 plus 14x. All right, so let's go ahead and solve this. First, I have to simplify both sides. I have to PEMDAS down. So I'm going to distribute that 7. I get 14x plus 21 equals 21 plus 14. So now let's, hang on, let's see if I wrote the problem wrong. 20 plus 14x. I thought I wrote the problem wrong. 14x. Okay, so now we want to get x's on both sides. Okay, I'm going to subtract the 14x from the left-hand side and then clean it up. 21 equals 21 plus 0. 21 equals 21. Notice how that's kind of a funny answer. My variable disappeared and I got something that this time it's true. It's not crazy like last time, it's just true. And that actually means something, right? So this is always true. And it means any x you plug into that, all x's, all values that you plug in for x will be a solution. That's weird, isn't it? All numbers are a solution. So you're either going to get an answer that happens to be true. -6, you plug it in here. It's the one answer that makes this true. Just one, no others, just one. So that would be the one answer choice, one solution situation. Or there's the crazy town situation, which means there are no solutions. Or there's the, yeah, that's true, which means all numbers are a solution or all solutions. That's it. The variables on both sides part of the lesson was to make sure that you knew that when there were variables on both sides of an equation, and in this case we had variables on both sides, and in this case as well, both sides, when you have a variable on both sides, you have to get the variables together on one side first, and then you can start to do PEMDAS backwards. Right? So PEMDAS backward. Cool.